Hi guys, welcome back to the kitchen for the last lesson on volume of three-dimensional shapes. And this time I want to talk about this one. That is a sphere. Now, what do you think about the volume of a sphere? For reference, I have that cylinder again. Same size, height, and same diameter for this cylinder and this sphere, or same radius if you want. How many of these spheres would it take to fill up that cylinder? Remember, if I have a cone with the same size radius and the same height, it takes 3 of these cones to fill up that cylinder. But what about the sphere? If I compare the shape of the cone and the sphere, the cone's a little bit, what would you say, puffier than the cylinder, and it looks like it would hold a little bit more than the cone would hold. The sphere would hold a little more than the cone. How much more? Okay, check this out. It's really cool. All right, I just have half the sphere here. Right, I'm going to fill that up with sugar and see how many cones I can fill with half the sphere. What do you think? Okay, here goes. Cone, half of the sphere. Try to do this without spilling. Check that out. Right? Half the sphere fills up one cone. And 3 cones fills up one cylinder, right? So how many spheres to fill up one cylinder? Well, we would need 3 halves.
There's 1 half from the cone. There's another half a sphere into the cylinder.
And there's another half a sphere into the cylinder. It fills it right up. And I'm totally making a mess. 3 halves to fill a cylinder. What does that mean about this thing? Well, that's 2 halves. In here, there's 3 halves. So this sphere must be 2 out of the 3 halves that are in the cylinder. So 2/3 the size of the cylinder. Okay, I'm going to take you over to the whiteboard, and what does that mean for calculating the volume of a sphere? Okay, so I've done my best to draw a cylinder and a sphere on the whiteboard here, and remember that the cylinder and the sphere that I was using in the kitchen, the cylinder has the same radius as the sphere, so I'm going to call it R, and it's exactly the same height as the sphere. That would be 1 radius and a 2nd radius, so the height of the cylinder is 2R. Right, now what would the volume for that cylinder be? It would be the area of the base, which is pi r squared because it's a circle, times the height, which was 2R. So if I kind of rearrange the formula a little bit there, the volume for this cylinder would be 2 times pi times r squared times r would give me r cubed. Okay, now what about the sphere? Remember, it took 3 halves of the sphere to fill up the cylinder completely. So 2 times pi times r cubed would be 3 halves of the sphere. But the sphere is only 2 of those halves, so it's 2/3 the volume of the cylinder. So 2/3 times the volume of the cylinder. Oh, I can just multiply out 2/3 times 2, get 4/3 pi times r cubed. So the volume for any sphere is going to be 4/3 times pi times its radius cubed. See you guys.